Hi there. In today's lesson, we are going to look at cumulative frequency graphs. So we're going to look at drawing and also interpreting cumulative frequency graphs. Okay, so this is a very typical exam question. You are given a frequency table including some grouped data. In this example, it shows the results from a maths test. So we can see that 3 students did quite poorly on the test. They got greater than 0 marks but less than 5. 2 students did very, very well on the maths test. They got greater or equal to 25 marks and less than 30. Okay, so what we first need to do is we need to work out the cumulative frequency. First, we need to know what the cumulative frequency is. The cumulative frequency is a case of accumulating the totals of each group as you work through the data. So, for example, when we go to find the cumulative frequency, we would add on a third column, and we're going to find a running total. So we're going to accumulate the totals of each group. So for the group of 0 and less than 5, we have 3 students. So there is 3 students. The running total is at 3. But for the next group, this total that goes here is going to be the sum of this group, but also including the sum of all the groups that are smaller. Therefore, we have a running total of 3 add 6, giving us 9. For the third group, we would go up to 19. We have a running total of 3 add 6 add 9, giving us 19. For our running total here, this value here will be a sum of this total and all the totals in the frequency column preceding this group. Takes us up to 32. For the next group, 48. And for the final group, we have a cumulative frequency of 50. So now what we know is this total here is the total of all of the students involved in this maths test. So 50 students is our grand total, our cumulative frequency total, which means that 50 students sat the maths test. Okay, so once we've worked out the cumulative frequency, we now need to go ahead and plot it on a cumulative frequency graph, which would be a visual representation of the data, and then we can use that to interpret the data for different needs. Okay. So we are going to plot the data, the cumulative frequency data, the accumulated totals. When we go ahead and plot them as coordinates, very important to notice that we use the highest value in the grouped data. So for example, our first coordinate is going to be plotted at 5, 3. Our second coordinate is going to be plotted at 10, 9. Okay, so I've drawn out an appropriate set of axes. Notice that cumulative frequency goes up the y-axis, goes up the vertical axis, and I've went from 0 to 50 and a little bit extra just to ensure that I can fit all the data onto this graph. My mark is out of 30, my lowest value being 0, my highest value being 30, so I've ensured the x-axis goes from at least 0 to 30, and again, it is labeled here. I've highlighted in red the upper bound of each grouped data because that is what is going to be relevant when we come to plot the data. Okay, so the first data point, as I mentioned, gets plotted at 5, 3. Where I've plotted it there. Then we're going to plot 10, 9. Then we move on to 15, 19. Then 20, 32. 25, 48. And finally 30, 50. So you'll notice that the starting values in each group do not really play an important part when we come to actually plotting the cumulative frequency graph. Okay, so just make sure that when you're plotting your values, everything is done correctly and your plots are accurately plotted. I've then went ahead and joined up my plotted points with a nice smooth curve. And you can see that this is not done with a ruler. It's not done like a dot to dot. It is a nice smooth curve. I've started from 0, 0 from the origin because my data starts from 0. But please be aware that not all questions, the data will start from 0. But in this example, it does. The shape of this graph is very, very typical of a cumulative frequency graph. It's sort of an elongated S shape. And you would expect that for most cumulative frequency graphs because we have a slight bit of data at the beginning of the cumulative frequency. Most of the data takes place in the center of the data. So that's why we have a sudden rise, a big incline here. And then at the highest point in the data, we have less data. So it's showing us the spread around the spread of the full data, with the top points there being less frequent data and at the bottom points less frequent data. So quite often you will see this typical shape of an elongated S showing on a cumulative frequency graph. Okay. Just a reminder that cumulative frequency always goes up the vertical axis. Okay, so what can we actually use this cumulative frequency to find out? Now we've got the data and it has been accumulated. What can we use that for? Okay, we could go ahead and find the median. There are 50 items in the diagram. There was 50 students who sat this test. We should know from our knowledge of averages that median is always the middle value. So if we have 50 students sitting the test, our median is going to be round about the 25th value, the middle of the data. Okay, so in order to do that, in order to use the cumulative frequency graph to find your median, I'm going to use my ruler and draw a line across at 25 until I hit the cumulative frequency graph, and then I'm going to continue that down to my x-axis and read off the value. Something like that. So you can see that my median is 17.5. Just like when we're using a line of best fit, this value is an estimate of the median. Because your cumulative frequency graph might differ very, very slightly from somebody else's, your median or values we're taking from the graph, we would usually refer to them as estimates. Okay, we also might be asked to find the lower quartile. For the lower quartile, we go along at 25% of the data. So the median is 50% of the data. We went along at the 50 percentile mark. For the lower quartile, we are going to go along at the 25 percentile mark. So we're dividing by 4 to find 25% of 50. Remember, 50 is how many students were involved. And I'm going to draw a line across at 12.5 until I hit the diagram. That's telling me that my lower quartile, as an estimate, is 12.2. I can also find the upper quartile of the data. So this would be the 75th percentile. So that I need 3/4 of the data this time, which tells me I need to look at 37.5 of my cumulative frequency. I need to read along until I hit my cumulative frequency graph, and then I read off my x-axis down here, telling me that my upper quartile as an estimate is 21.8. So I've used my cumulative frequency curve, I've used this elongated S to answer some mathematical questions here. Interquartile range is something else I may be asked for. Once we know the lower quartile, which we've took out of the graph, and the upper quartile, which again we've interpreted from the graph, to find the interquartile range, you would take your upper quartile and you would subtract your lower quartile, which would give you the interquartile range of the data. This would show us the spread of the middle 50% of the data. So you may also be asked in an exam question to work out the interquartile range. Okay, so here's a question for you to do. So group data of people who were surveyed about how long their commute to work took, how long it took them to arrive at work in minutes. So could you pause the video here and could you produce a cumulative frequency graph by completing the cumulative frequency table, drawing out a set of axes and completing the cumulative frequency graph, and could you also use that graph to find an estimate of the median? You have the ability to pause the video at this point. Okay, welcome back. Your cumulative frequency table should look like so with those values, and your cumulative frequency graph should look something like this. It might be slightly different to mine if you've went for a different scale on your X or Y axes, but essentially your cumulative frequency graph should look something like that. An estimate of the median journey time. There was 250 people who took part in the survey, which means that the median value will be found at the 125th value, the middle of the data. If we read along to touch the graph and then read down off our x-axis, that's giving us an estimate of 24 minutes for the median journey time. Okay, question 2. Again, you have the ability to pause the video at any point. Could you again go ahead and draw, well, first of all, complete the cumulative frequency table and then draw an accurate cumulative frequency diagram, again, using that diagram to find your median value. Okay, welcome back. Your cumulative frequency table should look like so. With the values here, we can now see that there was 180 fish sold at the market. If you were to go ahead and draw the cumulative frequency graph, it should look something like this. Again, look at the typical elongated S shape. The data does start at 100 this time. So you can see from the data we're starting from 100. So the cumulative frequency graph should not be extended to touch the origin in this case. We have 180 fish that were sold at market. So the middle value would be 90. We read along at 90 and down to get our median weight. Again, it's an estimate and we're looking for something in between 410 and 420 grams. Very well done if you have completed both of those questions. Okay, here's a final question for you to have a go at. So this time I've already drawn the cumulative frequency graph for you. I've added in the cumulative frequency curve. So this time I would like you to interpret that graph by having a go at question A, B, C, and D. Again, you have the ability to pause the video at this point, and then I will talk you through my solutions once you unpause the video. Could you please have a go at question A, B, C, and D? Okay, welcome back. I will go through my solutions and explain to you how we could have interpreted this curve to answer the mathematical questions A, B, C, and D. Okay, So you may have realized that it was probably easier to draw out the cumulative frequency curve. Once we've done that, then we can add some straight lines onto the curve to interpret the questions. So for example, the first question asked us to find the median. I knew there was 60 bits of data in this question. I knew that because the cumulative frequency curve stopped up here at 60. So this point here was the top of the cumulative frequency curve, which told me that I had 60 bits of data. Therefore, my midpoint would have been halfway through the data at 30, which is why I read along using this red dotted line until I hit my curve and read down. So my median is 27. Remember, that is an estimate. So depending on the accuracy of your drawing, anywhere between probably 25 and 29 would be accepted as a correct median. The interquartile range. In order to work out the interquartile range, I need to find out 25% of the data, 25% of 60 being 15. So I would go along at 15 until I hit the curve and down to find that my lower quartile is 21. Again, that is an estimate. For my upper quartile, I would need 75% of the data, so 75% of 60, which is 45. I read along using the green dotted line and down, giving me an estimate for the upper quartile as 37. So both of those green dotted lines are going to help us find the interquartile range, but they don't actually give us the final answer until we do a small subtraction over here to tell us that the interquartile range is 16. Remember, the interquartile range is referring to the middle 50% of the data. Question C asks us to find the number of aircraft arriving less than 45 minutes late. So this time we're still using the cumulative frequency curve, but we're doing it in the opposite way. So rather than coming off the vertical axis and down to the horizontal axis, we're going to start on the horizontal axis. So I'm going to start at 45 minutes. Following this blue line, I'm going to go up to meet my graph. Then I'm going to go along and read off my cumulative frequency at about 51. So what that's telling me is from this point here, underneath here is represented by 51 items, 51 elements in the data. So I know that the number of aircraft arriving less than 45 minutes must be 51, because if the 45-minute cumulative frequency is 51, that means that everything underneath must total to 51. Question D. The number of aircraft arriving more than 25 minutes late. Okay, so again, we're using the horizontal axis first, my x-axis. I'm reading up at the value of 25, up to touch the graph, and then along, giving me an estimate here of 24. However, the wording of the question talks about more than 25. So unlike question C, I do not want this value less than 25, which would be this value here. I want the value which is more than this total, more than this total. So I want all the data in between here, 24, and the top of my data, 60, which is why I've went ahead and done a small subtract. 60 take away 24, telling me that the number of aircraft arriving more than 25 minutes late is 36. Again, all answers are estimates, so there would be a little bit of leniency with your answer if you are 1 or 2 numbers out. Okay, if you've understood everything in this video and you've been able to have a go and accurately get your answers for question A, B, C, and D, very well done. You've shown a good understanding of interpreting and drawing cumulative frequency graphs.